Hi, so we are going to finish up the properties of quadrilaterals, and today we're going to talk about the ones that are not parallelograms. So that would be the trapezoids, the kites, and all that good stuff. Sorry, just trying to get this all set. It was, I don't know, apparently wiggled over the night. So first we're going to talk about trapezoids. Remember, the definition of a trapezoid is a quadrilateral, a closed four-sided figure that has one set of parallel lines. And I'm going to draw this on here, though you don't really need to because that's part of the definition. Those are the parallel lines. So the only thing that you can use algebraically really in a regular trapezoid is that the angles that are between the parallel sides, this pair here and this pair here, are supplementary. And hopefully your brain will tell you as soon as you see that word, that means that they add up to 180 degrees. So that would be this angle here and that angle there. Those are supplementary angles. And this one and this one, consecutive angles, means angles in a row. This makes actual sense because if you think about the fact that those are parallel lines, if we cover up this one, then these two are same side interior angles, which we know are supplementary. And same over here, same side interior angles are supplementary. And that really is the only rule that we can use when we're talking about a plain regular trapezoid. So if we look over here at this example, it tells us it's a trapezoid, and we just have to find the missing measurements. If this is 76, I'm going to kind of use the same notation I used on the other one. Consecutive angles are kind of like that. They're in a row. So if this is 76, to figure out this missing one here, we would do 180 minus 76, which is 104 degrees for angle A. For angle C, over here, we're going to use this other set of consecutive angles. Consecutive angles in a trapezoid are supplementary, the ones between the parallel lines. So 37 degrees for angle C. All right, hopefully that makes sense. And just to verify, the angles in a quadrilateral add up to 360. So if we added all of these up, it should equal 360 if we did it right, and we did. All right, so that's for just a regular trapezoid. When it's isosceles, the definition of an isosceles trapezoid is that they have the two parallel lines, sides, and that the legs, which are these pieces here, are congruent. That's what makes it an isosceles trapezoid. So while this isn't really a property, you can use it as a property. The base angles, that would be down here if you think about it being part of an isosceles triangle, but they also count up here too. Each set of base angles are congruent. So these two are congruent to each other, and those two are congruent to each other. And it seems funny that they could both be called base angles, but if you kind of flip it upside down and put the other ones on the bottom, that would make sense. All right, also they have the same property where consecutive angles are supplementary. So these two would be supplementary, and these two would be supplementary also. All right, diagonals, just like on the other one, diagonals go from one vertex to the other. And because these are consistent, the diagonals are congruent also. The other parts of the diagonals that are congruent, which we're not going to write as a property, but it would be good to know, is that this little part is congruent to that little part, this segment of them, and this one to this one. All right, so while that's not really a property, it works every time, so it's something good to keep in mind. And then opposite angles, just like with parallelograms, opposite angles are the ones that are totally across from each other, like that. Opposite angles are supplementary in on an isosceles trapezoid. All right, so those are the properties. Let's look at a simple example. First, it tells us this is an isosceles trapezoid, so that automatically means that these are the same. As soon as those are the same, then that means that the base angles are congruent, and these are too. So here we're really dealing only with angles. If this one, angle S, is 71, it means the angle V also has to be 71, because in an isosceles trapezoid, base angles are congruent. Based on the properties of just every trapezoid, consecutive angles between the parallel lines are supplementary. So we could do 180 minus 71 would be 109, and that would be the measure of angle T. Okay, because consecutive angles are supplementary. And we could do the same thing on this side, or we could use the rule that opposite angles are supplementary, and still it's that same calculation right there. You could also use that base angles are congruent and put the 109 in without doing any math. All right, so those are the properties of an isosceles trapezoid. And now we're going to talk about kites, which are super cool. All right, consecutive again means the sides that are in a row. So the definition of a kite is a quadrilateral, a closed four-sided figure with two pairs of consecutive sides that are congruent. So this one, then that one, those are congruent. This one, then that one, those are congruent. We can draw the diagonals in a kite. 1, 2. And you can notice even just by my drawing, but we could prove it if you wanted me to, just come see me, that the diagonals are perpendicular. And hopefully your brain knows that this is the symbol for perpendicular, and that means that they intersect at 90 degrees. All right, which is really cool because that means that you have, I'm just going to highlight one of them, but you really have 4 right triangles. And as soon as you have right triangles, you can use trig, you can use the Pythagorean theorem, you can also use special right triangles, which we're not talking about until later. Okay, and just another cool thing, I'm going to do the one on the bottom, but there's one on the top too. If you combine these like this, you really have an isosceles triangle as well, which means that you have these angles that are congruent and all of those properties that go along with that. Also, I'll go over this one and then some other cool things. One pair of opposite angles, so that would be this pair. That pair of opposite angles is congruent. The other ones are not. Okay, more cool stuff about kites. Because this diagonal here, it's actually a perpendicular bisector, so it cuts this in half. So this piece goes, goes with this piece. And it bisects this angle here too. And this angle. So while those traditionally are not stated as properties, they are true with all kites. And so just kind of keep that in mind. It's a crazy diagram, but that's because kites are really cool. And just for clarity, these angles are not bisected. Okay, they're not bisected. So let's look over here. This is a simple version. ABCD is a kite, and we want to find these two measurements. Well, these are fine, given, and we don't know anything else. However, we do know that these are both congruent angles because they have one pair of opposite angles that are congruent. You can do this two ways. You can either make these both x, or variable of some kind, and write an equation, x plus 85 plus 43 equals 360, because that's the total number of degrees in a quadrilateral, and then solve that.